Hi, this is Paul, City Sailing. This is a tutorial on course to steer. So just to recap, we've talked about estimated position. If that means nothing to you, then we have our own tutorials on estimated position. So the recap on estimated position, you know where you're starting from, so you're at a fixed position. You know you've been sailing on a course for a certain time, and you know where you are now. So here we go, the boat starts at the bottom here. We know where we've gone, we know how far we've gone, mark it off, and this is our dead reckoning position. But during that time, the tide has pushed us, and the boat has sailed in this course with the tide pushing us, and the effect of the tide is from the end of your DR to where you are now, which is your estimated position. There we go, there's tide, estimated position, and from where we start to where the vessel is, the effect of the course we're steering and the tide will give us the course over the ground. So this is how we worked out the estimated position, and we've already done a tutorial on this. So now we're going to talk about course to steer. So course to steer, you're at a fixed position. What course do you steer to reach another position? So we want to predict what course to steer, allowing for the wind and tide if you want to go from one position to another position. Here we go. So you're at A and you want to go to B. You estimate your speed to be 6 knots, 6 nautical miles an hour. Variation is given to you, 7 degrees west. The tide is 020 degrees at 2 knots. What is your magnetic course to steer? So draw a line from A through where you want to go at B, and that'll be your course over the ground. So when you draw your line A to B, extend it beyond B. So don't stop at B, add a bit more, and this will become apparent a little bit later on. So A is where we are, B is where we want to go. Draw a line between them, and this will be our course over the ground. So measure the line AB. So in this example, AB equals 5.8 miles. We have a boat speed of 6 knots, so it will take us about an hour. So you need to know to the nearest hour or half hour, so you can work out how much tide is going to be affecting you during the passage. So A to B is 5.8 miles. We're doing 6 knots. In 1 hour, do 6 miles. So it will take us about an hour. So we'll need to construct 1 hour tide. So we work this out with a tidal diamond or tidal stream atlas. If that means nothing to you, then we have tutorials on working out tidal flow on the City Sailing. So from A at the beginning, construct 1 hour of tide, 020 degrees, 2 knots. Because it's an hour, it'd be 2 nautical miles. From A to C, it'd be 2 nautical miles at 020. So that's the amount the tide's going to affect us for the time during the passage, which would be 1 hour. So we know the boat is doing 6 knots. So in the hour, it will do 6 nautical miles. So we measure the 6 nautical miles with our dividers on the side of the chart. We then take the end of our dividers and we put them on C, and then we mark the dividers or arc the dividers across the line A to B, which is extending out, and where it crosses a line, we mark it. It is important that our dividers are kept at 6 miles. Do not join C to B, because C to B is not 6 miles, it is not an hour. It is a rabbit hole that you will fall down once, so do not join C to B. It should be C to D, because C to D is 6 miles. So we joined C to D. So C to D is 6 nautical miles. So C to D, it says there, speed of the boat, water track. So to convert the true from the chart to magnetic, do your TVMDC with magnetic of 117 degrees, apply the variation of 7 degrees west, which gives us a true of 110 degrees. If you measure the length from A to D, this is how far you've travelled in an hour over the ground. So that will equate to your speed over the ground. So this will only work for a period of 1 hour. In this case, the speed over ground is faster than the speed of the boat through the water, and that's because the tide is in our direction. If the tide was going against us, speed over the ground will be less. And here in this diagram, the tide is going against us, so C to D cuts just before B. So it will take longer than an hour to get to our destination. So let's consolidate this with a course to steer question. So the example will be, on the 11th of September, starting at 14:30, you sail from the east entrance to Parvin Sound, north of South Douglas Island. It's on the middle top right of RYA Chart 3, and we're going from there to Farlow River. Your estimated speed is 6 knots, variation is 7 degrees west. Use tidal diamond C for your tidal set and drift. And the question we're asked is, what is the magnetic course to steer? What is the speed over the ground? So we mark off A and B. So A is at the entrance of Parvin Sound, B is Farlow River. So measure the distance between A and B. So we need to know how long it will take to the nearest half hour. In this example, A to B is 6 nautical miles. With a boat speed of 6 knots, it will take an hour. So we need to plot 1 hour of tide. So we need to calculate the distances of the set and drift using tidal diamonds or the tidal stream atlas before popping it on the construction of our chart. So we work that out. To calculate the tidal streams, use the tidal diamond or the tidal stream atlas. The RYA question will tell you which one to use. So stick to that one in the RYA questions. So on this one, it was a tidal diamond. We go to the tidal heights of Victoria because all tidal flows are from Victoria. So we go to Victoria, 7th of September. High water 1308, low water 1909. 11th September, the period is 1430 to 1530, and this falls between 1308 and 1909. And we want the high water and the low water to work out the range, to work out whether it's springs or neap tides. And we also want to work out if we're in the shaded or non-shaded area. In the non-shaded area, as it says in the top right of the page, we have to add 1 hour for summertime or daylight saving time. So high water 1308, height 5.5. We add the hour for summertime, so high water becomes 1408, height 5.5. Low water 1909 and a height of 0.8. The range is the difference between the high and the low, so it's 5.5 minus 0.8, which is 4.7 meters. If we look at the box in Victoria tidal curve on the top right hand side, we'll see mean ranges, springs 4.9, neaps 2.4. So where it says springs there, our range is 4.7, so that equates close enough to springs, so we take it from the springs rate. So the time required, starting at 14:30, so we put a high water time of 14:08, high water +1 at 15:08, high water +2 at 16:08. We split into the half hours, so we've got 14:08 plus half an hour is 14:38. Then we've got the high water +1 at 15:08 plus half an hour, 15:38. So the time we're looking for is 14:30 to 15:30, fits between this gap. Look back, it's high water +1. Using tidal diamond C, because it asks us to do this in the question. There's tidal diamond C on our RYA chart 3. We go to the tidal stream on the tidal diamond, high water +1, C, it's 173, 1.2 springs, 0.6 neaps. We worked out its springs, so the direction is 173 degrees true, speed 1.2 knots. So tidal diamond C, high water +1, direction is 173, 1.2 knots. So draw a line from where you are, A, through to B, and extend it out. There we go. A to B, extend it out. Construct the tide from where you are. So here we go, so here we are. We pop the tide on. So the tide is represented between A and C for the hour of us travelling. Construct the water track. So using C as a centre with a radius, which is the speed of the boat, 6 knots. We're going for an hour, so it is 6 nautical miles. So put your dividers to 6 nautical miles, mark an arc across from extended A to B. There we go, from the end of the tide, 6 knots, 6 miles from C, and it will arc across our line at D. This diagram is for 1 hour. 1 hour tide equals 1 hour speed. So the angle of CD is your course to steer. So if you put your plotter on there, twist the middle round, so little arrow at the top, big arrow where you're going, and you'll find that the angle at CD is 112 degrees true. True, 111 degrees, variation 7 degrees west, magnetic 118 degrees. Now we want to calculate the speed over the ground. Measure the length of AD to find the speed over the ground. So if you measure the length from A to D where it arcs across, will be our speed. So A to D equals speed over the ground, which equals 6.3 miles. So in an hour, we'd have got to here, but we don't want to get to here, we want to get to here. So if we look down there visually, that'll be an hour, so that will be about 50 minutes. If you're travelling for more than an hour, you want to plot all the tidal streams from A after each other. So in this example, we've got the first hour, the second hour, and then we'd plot for 2 hours, arc down this line, how far we've gone in 2 hours, arc it across. If it's for 4 hours, we plot the 4 hours on there. If it's a lot further, like crossing the channel, we would have to mark them off on there. So it's 6 nautical miles. So that's all the tides going west of the channel, goes like all the tide going east of the channel. And we can factor that on. And because the tide's going this way, then back this way, then back this way, although we're heading on this course to steer, the actual boat will go in this shape to Cherbourg. So if we're travelling for 12 hours and there's no obstacles in the way, we'll be heading straight from where we're starting to where we want to go to. Most of the course to steer will be in an hour's period and doing a short distance. So that is course to steer. Stick around, we're going to do an example. We're going to do an example which is going to be pretty similar to an assessment. So stick around for that in our next tutorial. Hope you've enjoyed the tutorials. Hope you enjoyed the city sailing videos. There's lots on the website, citysailing.com, and we hope to see you soon. Thank you. Bye.